Welcome. My name is Harrison. Today we're talking about leveraging osquery data from Fleet for device health using some low-code solutions. So the idea of this talk came from realizing that I've seen some teams that wanted to implement some sort of device posture check solution, but didn't have the full resources to bring on a tool. So what I'm going for here is kind of demonstrating a repurposing of tools that you have already in your tech stack and maybe extracting some more value out of them. So who am I? I am based out of San Francisco, California. I'm a platform and identity engineer at an Australian company called Deputy. And before working in tech, I bounced around kitchens all over the Bay Area and was most recently a sourdough bread baker. So the tech stack that we're talking about today, so Fleet, which is our open source tool that exposes the operating system as a high performance database. JD did a great overview of that on the workshop on Wednesday. We self-host all of our infrastructure in AWS. We're using Okta workflows in this example for some low code, and then Slack for our end user communication. Workflows for this one, you could use Tines, or you could use that weird one that only JD uses, N8N. It would all work the same. Okay, so Zero Trust. It's a framework that we have adhered to for a while now, but we were looking for a more granular way to ask questions about our devices in order to make authentication decisions. So looking at things like Chrome OS versions or vulnerabilities in JetBrains IDE, but also looking at other configuration changes. So is the CrowdStrike filter enabled and is the sensor loaded correctly? But also looking at things like nudge. Are we loaded in the user space? Are we looking at the correct configuration file? So through that, we can use policies in Fleet to evaluate whether these things are pass-fail. On the left there is an example of some of the policies that we check for in our prod environment. And then on the right is kind of an example of how those devices show up in each of the policies. Down below is a simple-ish example of how we use osquery to check if the CrowdStrike network filter is enabled at all times. So I'm a big fan of succession, so I'm going to use that as my cast of characters today. So it basically starts out with a manifest that we maintain that has all the managed devices from our MDM. And we have the associated user and then some other metadata about those devices. And then at a set interval, we're iterating through those devices and checking the critical failing policy count against Fleet's health endpoint. So here you can see we have one policy that's marked as critical that's failing. And then down below is just any other failing policies that we have for that device. Here's where we do the flexible decision making. So in our environment, in this example, we're saying that no device that has a critical failing policy can sign in, but you could also do an evaluation of policies in general that are failing, and you could look it up by like a policy ID, or you could do any sort of configuration that would work for you. And then we're just updating that table from the previous example to change the status from passing to failing. And this is kind of back at that main manifest. It looks like here we're going from true to pass false. So now we know the device is failing, so let's take an action. On the left is just where we're suspending the device in Okta. And then on the right, we're making another call to that health endpoint because we're going to want that remediation data later on in the flow. And then here's just an example of calling a helper flow. You can see the device and then the remediation steps that we're going to send to our end user in Slack, which is going to look like that. So Milo is our outward-facing IT bot that we send all of our communication from. So here we're sending a Slack message to the user. We're indicating the failing policy and then the remediation steps, and then telling them what to do next after they've done the fix. So the user remediates, and then they can go back into Slack and do a /command fetch. They see this cute little interaction, but under the hood, we know which device and which user is calling the command. So then we go back to Fleet and we make a refetch call to the endpoint to then evaluate, did that status of the device change from failing to passing? And if it did, we're going to call another helper flow. So at this point, we're going to say the device is now compliant. and we're going to unsuspend it, and then we're going to send one more Slack message to the user. Otherwise, just it goes back to the beginning and resends that remediation Slack with the steps needed, and then just exits. Here's an example of just building that last call and then sending the payload to the Slack API. And then if the user passes all the checks and everything is good, Milo then follows up with this message saying that their device is compliant and they can sign in again, and then how to get some help. What's to come, I'll cross-post this on my blog, but this is a great video that Zach and the guys at Fleet made around next steps on this. We would love to see Fleet and using it as like a third-party IDP to evaluate like policy and health checks at time of authentication, and then kind of presenting the user with a nice little example there. I just want to thank my team at Deputy, thanks Dave and the Fleet team, and thanks to the Mac admin community. Connect with me on LinkedIn, and I have a blog on the right there that I don't update nearly enough. And yeah, thanks for listening.